Hi everyone, welcome back to another video. So in the last video, we went through the ultrasonic sensor module. And so in this video, we're going to be going through membrane switch module. I've got no idea what this is, so let's have a look at it together. Lesson 10, membrane switch module. In this project, we'll go over how to integrate a keyboard. Okay, so the membrane thing from a keyboard with an Uno R3 board so that the Uno R3 can read the keys being pressed by a user. Okay, so I'm assuming it's going to be the keypad remote control IPC. Is it that? I don't know. Okay, let's just carry on. Keypads are used in all types of devices, including cell phones. Really, cell phones with keypads nowadays? Fax machines, microwaves, ovens, door locks. They're practically everywhere. Tons of electronic devices use them for user input. So knowing how to connect a keypad to a microcontroller such as an Uno R3 is very valuable for building many different types of commercial products. For this project, the type of keypad we will use is a matrix keypad. This is a keypad that follows an encoding scheme that allows it to have much less output pins than there are keys. Much less output pins. Okay, got it, because using the matrix. Okay, I got that. For example, the matrix keypad we are using has 16 keys, 0 to 9, A to D, star and hash, yet only 8 output pins. With a linear keypad, there would have to be 17 output pins. Yep. The matrix encoding scheme allows for less output pins and thus much less connections that have to make for the keypad to work. Okay? In this way, they are more efficient than linear keypads, being that they have less wiring. Alright, fine. Yeah, so it is this one. No, wait, it's not that one. Is it? No, it's not the remote control. Where's the other keypad? Okay, there. Membrane switch module. I haven't gone through this kit yet, but is it just me or am I blind? I can't see it. Oh, there it is. It's underneath. Nice. So it's literally just a paper thin keypad for membranes. This is cool. I love this. This is brilliant because you can literally just stick that onto the top of anything. And now you have a fully working keypad. How simple that is. Just 8 pins with a little ribbon cable. That is fantastic. Oh, I'm telling you, I'm excited for this. So we need the membrane, we need the Uno R3, and then male-to-male jumper wires, and we need 4 of them. I'm not sure what color I'm going to need yet, so we'll just put them all aside right now. I want to try and stick to the color scheme. Oh wow, here's the circuit diagram. So it looks confusing because that's obviously just in terms of all the keys there. How's it laid out? 1, 2, 3, 4, 5, 6, 7, 8, 9, star 0 hash. And you've got A, B, C, D. Trying to make sense of this diagram is a bit messy. Okay, that's confusing like that. Let's see the circuit. That's more readable, I suppose, in terms of where things are going. Okay, so let's try and follow this then. We don't even have the right colors here. This is going to get messy. Okay, I'll try and stick to as best as I can. So we've got like a blue. Okay, let's look back at the schematic. I noticed nothing connected to 5 volts or ground, which is interesting. Okay, this is gonna get very confusing. So blue into the top here, not really going in. Okay, there you go. So blue into the top and it's laying like that. So I'm just following the wiring diagram. Now we've got like a purple. Let's just go with a lighter blue. This is gonna get messy. Basically, in this instance here, it's not really worth, I don't think, our time to try and color code it. May as well just chuck wires at it because it's gonna get super confusing anyways. So I would just go with just different color wires basically. So put all of these wires in this side. It's ideal if you can stick to the color scheme. Doesn't help that I'm picking different length wires as well, which is silly. Okay, there you go. Just got a bunch of wires there all connected up. Okay. So now we can just do it in in terms of order, which isn't ideal, but so we're not using the analog pins, we're using the digital pins. So as an analog, we're going to use these digital pins. So let's start from the top. So the top one is going to pin 2. Oh, it's kind of like, okay, it's the opposite. Do it like that. So that's in top one's in pin 2, and then the second one is the blue one. I've picked too short. The wires I've picked are too short. Let's replace that. We'll go with a longer orange one. The second one's going to pin 3. I think it's just in order from here. So white. The third one is going to, yes, it's just 4, 5, 6, 7, all the way up to 9. Okay, that's nice and easy. I was overcomplicating it a bit. So that's 4. And black here. 5. 3. 1. Orange to 6. Oh, my things popped off on this. The good thing is it pops back on. Doesn't want to stay in. 6. And yellow is the next one. Oh dear, it's all just falling out on me. 7 and then green. 8. Lastly, red is the last one. It now just need to make sure they're all plugged in. They're not the best, but what can you do? I mean, it doesn't help that they're all different lengths as well. Okay, so when connecting the pins to the Uno R3 board, we connect them to the digital output pins D9 to D2. We connect the first pin of the keypad to D9. Okay, so this is saying that this is the first pin. I was reading it from that way, right to left, right, but from here, that one being the first pin. So 1 to D9, etc. Okay, so it says here that I should see lesson 5 if there's any errors uploading. So I'm going to assume again that we're going to get the same errors that we get every tutorial, and that's fine. So we're going to have to upload the header file. Okay, so let's upload our code now. First, I'm just going to export this. So look, we've got an object, C++, and we've also got the keypad.h header file. So we're going to put both of those, extract both of those into our folder with our code. So here, into here, put that into there. Okay, so I've put the header file and the C++ object file into the code, the folder with the code, and then now I should be able to just upload it and it should just work. Okay, so let's hit upload. Hopefully no errors. Yeah, look at that, it worked. This tutorial series is funny, isn't it? When you don't add the header file, it doesn't work. When you do add the header file, it doesn't work. Responding to my key presses, you can see the LED blinking. 5, 6, 3, 9, yeah. So it's definitely detecting all key presses. Let's take a look at the code now. With this code, once we press a key on the keypad, it should show up on the serial monitor of the Arduino software once the code is compiled and uploaded to the Uno R3 board. Hit the serial monitor button, etc. Okay, so that's all we're doing then. Alright, so we're just clicking serial monitor, and then we're just going to start pressing things and seeing it respond. So 0, 0, 0, 1, 1, 2, 2, 3, 3, AA, 4, 4, 5, 5, 6, 6. Brilliant. Look at this, this is amazing. 7, 7, 8, 8, 9, 9, DC, star, 0, hashtag D, 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 D. Yes, it's fully working. Now would be the hard challenge of doing something with this code. I'm even struggling to understand what's happening here. So we've got constant byte rows. So we're making a variable equal to 4. Then we've got 4 rows and 4 columns. Okay. And we've got like this isn't an object. I forgot what it's called. Structure. Looks like we've got a structure here. We've got an array, a struct. Okay, so this is a whole bunch of declaring variables and basically initializing each row and column and telling it what's inside each one, basically. So giving it the value of each one. So I could change, for example, A to C or A to, let's say, T, and hit upload. And then when I press A, it will spit out T onto the serial monitor. So A, T. That's just basically telling it that what this membrane is A. Okay, so what I would want to do with this, and I don't think I can do it for you now, just on the basis of why my current level, is I would want I would want to ask the user to enter a password, right? And then take their input, put it into a variable, and confirm that the keypads that they pressed, you know, in that order were equal to that password, which I would have no idea how to do on this Arduino. So the basis of our code here is we're setting up serial begin. I assume that means starting the serial monitor. And then we're putting whatever key is pressed into this variable custom key. And then we're saying if custom key is pressed, then print its value. What's interesting here, which I can definitely show you, is if we remove this if statement, right, then it's just going to print constantly the value of that custom key. Let's show you that. We hit upload, and I wonder what it will spit out when there's nothing pressed. So it should, okay, yeah, so it's just spitting out blank. Look at that. And now if I press 1, okay. So it prints out 1 and then it clears. So 1, 1, 1. It just carries on spitting out blank. Okay, yeah. So that's the purpose of the if statement. The if statement is saying only when you detect a press, then print it. Other than that, I don't really know what I could do with this code. Apologies if that's what he's looking forward to with this one. I'm not at the level yet where I think I could do something with this. It's a real shame that in the tutorials for these, they don't give you something to do with this. I'm trying to think of something, but my mind's coming up blank. Okay, I've got an idea. I'm going to try something here, and if it doesn't work, then you will never know about this this part of the video because I'll just cut it off here. So I'll just do my little ending here, which is, if you enjoyed this video, leave a like, and if you haven't subscribed, please subscribe because I'm going to be coming out with a lot more content like this. Sorry I couldn't add anything to this video, and yeah, hopefully I'll see you guys in the next one. Let's just check what the next one is. Next one up is DHT11 temperature and humidity sensor. Nice. The humidity sensor, I've got some cool ideas for that. I'm thinking of doing like a plant irrigation system. So that humidity sensor should be a cool project. So yeah, I'll see you guys in the next one. Peace. Okay, so if you're still here, then that means that I was successful in doing this. So let's get to it. At the moment, I don't know if I'm going to be successful. So yeah, let's give it a go. All right, so here's the plan. The plan is that when 6 is pressed, turn this LED on. Otherwise, keep it off. So if you imagine, for example, we had a password, you wanted to enter a password, we're going to say, a better password would be, once the correct sequence of things are pressed. But I'm just going to just do 1. So first, I can't remember how to turn this LED on or off. Oh, wait, it's that LED, isn't it? One of these LEDs anyways. I think it's that LED there. So let's open up our blink sketch. I feel like none of you are ever going to get to see this video because this part of the video anyways, because I'm going to delete it, but we'll see. All right, so this is the blink sketch. This is the code for how to turn the LED on and off. So I want this part of the code. Let's delete this. Oh, it's copied the comment. Okay, here we go. All right, so I want that part so I can close this blink now. Save changes, nope. Okay, so let's just put this bit in comments for now. Can you do these kind of multi-line comments? Yes, you can. Nice. Like C programming. Okay. So we're going to say if custom key is pressed, print custom key. Instead, what we're going to do is we're going to say if custom key is equal to I don't know, 6. If it's equal to 6, then print custom key should do just fine. Let's try that. So it should only print when 6 is pressed. We'll try that. So upload. I'm just happy to see that the code actually worked. Okay, so serial monitor. So now 1, 2, 3, A, 4, 5, 6. Nice. B, 7, 8, 9, C. Look at that beauty. So only 6 works. Okay, so now let's see if we can get the LED. So another thing you could just do like a nested if statement, another if statement inside this to say, okay, once 6 has been pressed, then check to see if 5 is pressed thereafter. So try that. This is gonna get Okay, first let's try and turn the LED on, and then maybe we'll build on this. Okay, so we're gonna say make the digital pin high. So first let's comment out this bit because I don't want to lose this bit. So comment that out. So we're gonna make the LED go high. Let's also make the LED go low on every loop of the program. So right at the beginning here. So the LED is gonna go low first, so turn off the LED. Then if 6 is pressed, the LED should turn on. Okay, that doesn't seem like the best logic to me. I think there's gonna be some gaps in it, but let's see how that goes first. So the LED is currently off or on. I don't know. Okay. I can't remember which LED it is that's controlled by the Arduino, but that's fine. So 1, 2, 3, 6, 5, 6. No, I'm not getting anything. 890 A6. Okay, let's try it this way. I think the issue is me turning off the LED on every loop. Maybe 6 is turning on the LED, but only momentarily. I could add the delay actually. Let's do delay 2 seconds. Maybe that'll make it more clear. It's quite difficult when you're programming, especially real programs, when you're dealing with real time. You know, we can't see an LED turn on for a millisecond. Okay, so I've uploaded, turn on serial monitor. I don't even need serial monitor, do I? So 1, 2, 3, 6, 5, 3, 6, nothing. Okay, let's try an else statement instead. So okay, wait, maybe let's just try putting in it, make it go low here. I mean, do I need to maybe declare this LED built in variable? I don't know. Remember, like I said, I was not confident I'd be able to get this to work. So if you are watching this, just some miracle happened. I don't know how I got it to work. Okay, so LED is currently, it's on or off? It's on right now. Wait, if I close the serial monitor, what happens? Okay, let's try it without the serial monitor being on. 3, 6, 5, 6, 9, 8, 5, 6, nothing. I can't remember what. Another thing we could do is maybe, do an external LED. That's getting a bit deep now. Um, it hurts, man. It hurts. But I am royally stuck. Okay, let's do if make the LED go high, and then we're gonna do an else go low. Upload. Okay, it didn't like my something. Expected declaration before the curly bracket. This is the else one. This part is for the loop. Okay, they need to be here. Interesting. All right. Upload again. So the LED is currently off, but then it turns back on. It is. It's this L LED, isn't it? That's the L LED that we're supposed to be controlling, but it's turning on. Ugh. Okay. Let's try in the setup to turn it off first. So void setup digital right LED low. Maybe it just turns on as standard. It's currently off. It turns back on again. Bloody hell. Okay, let's not try and mess with the LED anymore. Yeah, at least the built-in one. Let's do if custom key is equals to 6. And then if again custom key is equal to 7, then print password accepted. Okay, so upload. So now I'm saying that once 6 and then 7 is pressed, then accept to say password accepted. Okay, so let's open our serial monitor. So now if you press the other keys, nothing should happen. Okay, so now 6 and then 7, nothing. 9, 8, 6, 7, 6, 7, nothing. Yeah. Ugh. Okay, so what's happening here, I think, is that it's going if equal to 6, okay, then come into this code and then exit the code straight away because I'm not pressing 7, with it whilst it's in there. So I assume I need to add like a 10-second delay to 10,000 or something and then try it. It's probably exiting the if statement and then going back to the loop again. So let's try serial monitor. So 6 and then 7. 6, 7, 6, 7, 6, 7. Nah, can't get it to work. Okay, so sadly I wasn't able to finish this tutorial. This is kind of like what I tried to do, but didn't have any success. Is what it is. But thanks for watching anyway, anyways, guys, and I shall see you in the next one. Peace.